network theory or circuit theory, whatever you call it, this is a subject which is the foundation for electrical engineering. If you are not clear with the concepts in networks, then other subjects will also become difficult. And in the same way, if you find this easy, if you are very well versed with the concepts in networks, then every other subject you're going to find it much more easier. Alright. So, what is the very first thing that you're going to study here? You're going to start with charge. Where do you find charge? In an atom. Okay. The electron in an atom has a negative charge. There are two kinds of charges, right? Negative and positive. So, electron has negative charge and proton, which will be present inside the nucleus of the atom. This is going to have a positive charge. What is the other kind of particle you have in an atom? It is called as the neutron. This is going to be neutrally charged. That means it is not going to have either positive or negative charge. Okay. Now the next question is the units. Units are also very important. So what do we measure the charge in? We measure it in coulombs. Okay. Now the next question comes. How much coulombs of charge is carried by an electron and a proton? Okay. So what is the charge? For an electron, the negative charge is going to be minus 1.6 into 10 to the power minus 19 coulombs. Okay. So one electron will possess this much amount of charge. What about proton? The magnitude of charge is same, just the sign is going to be different. So plus 1.6 into 10 to the power minus 19 coulomb. Okay. So again, what will be, this is the amount of charge in one electron and proton. Okay. Next thing that you need to know is how many number of electrons will combine to form 1 coulomb charge. Okay. So this you are going to get 6.24 into 10 to the power 18 electrons, number of electrons. Okay. So each electron has 1.6 into 10 to the power minus 19. If you multiply these both, then you're going to get 1 coulomb. Okay, so that is the meaning of this. Similarly, this is minus 1 coulomb charge. If it is plus 1 coulomb charge, then it is going to be the same number of protons. So this is all what you can call as the origin of charge. Okay. Now, what is another important point about charge? The very important point is the law of conservation of charge. What does this state? It states that charge cannot be destroyed nor it can be created. Charge can neither be created nor destroyed. So this is one of the basic laws, law of conservation of charge. So this is all about charge. Next, what do we have? The current. We have talked about charge. This is represented by Q. Charge is represented by Q. Now, if a charge is moving, then it is called as current. Okay. So the current is defined as rate of change of charge. Okay. So basically, it is nothing but a moving charge. Moving charge constitutes current. And how will they be related mathematically? The current I, current is represented with I. This is equal to dq by dt. Now at this point, I want to tell something important here. Whether we use capital letters or small letters, right? Because current, if you take, we often represent with a small letter and we also represent with a capital letter, I. Okay, so what is the difference? So when you are using a small letter to represent an electrical quantity, it means that it is time dependent, and in fact this is more universal. Okay, even a constant function can be represented with a small letter. Okay, but if you are using a capital letter, then it means that it is a DC value. That means a constant value. Okay. So for example, let us take this is time, let us say, and the charge, for example, it is represented like this. See, it is constant. And what is this constant value? This capital letter Q. Okay. Now, Q of t, the time dependent variable charge, it is equal to Q. Okay. So, basically we are expressing it as a function of time. That's all, nothing else. Okay. But if it is capital letter, then it means that it is a constant value. Constant value means DC, direct current, right? So we will discuss once again about direct current and alternating current a little while later. But for now, constant value we can also write as or DC value. Okay. So now here this function we can write even a little more better way. I of t, okay, the current as a function of time t, this is going to be equal to differentiation of a function which is called as Q of t. Okay, so that is the correct representation, more accurate representation. Okay, now what about charge? How can charge be represented in terms of current? Okay, so you just have to integrate, right? So the charge Q of t will be equal to integral I of t dt from a particular time t1 to t2. If you take the limits, then you don't need an arbitrary constant. If you don't take the limits, then you will be needing some arbitrary constant. Okay, so that means what? You can either write as this with limits, or you can simply integrate I of t dt plus Q of t naught, where t naught is the initial time. So Q of t naught is the initial charge. Okay, so this is how you complete the integration, you perform the integration. So we will do a few simple problems here. Okay, so given charge Q of t is equal to 5t square plus 2t, then find current at t is equal to 1 second. Okay, so before you see the solution, you can pause the video and you can solve it on your own first. Okay, so now what is the solution? The current, you have to find the current simply, and this is equal to dq of t by dt. You just have to differentiate the charge function. So what is the differentiation of 5t square plus 2t? It is 10t plus 2. And when should you find the current? The current at instant t is equal to 1 second. Okay, so I of t is equal to 1 is equal to 10 times of 1 plus 2, which is equal to 12 amperes. So this is one question. Another question, now instead let's say we have the current. Okay, so let current through a conductor be I of t is equal to t by 2. Then find amount of charge that has passed from 0 to 10 seconds. Okay, so here as well you can pause and you can do the question yourself first. So it is given, the current is given, I of t is equal to t by 2. Then what about the charge? How will you find the charge? See, basically you have a conductor here and a current I of t is flowing here, which is given by t by 2. Okay, so now if you take any particular cross section, what is the amount of charge that has passed through this cross section in the duration 0 to 10 seconds. Okay, so this is going to be Q of t is equal to integral, since limits are given, you don't have to worry about the initial charge. So 0 to 10 I of t dt. So what is the integration of t by 2? It is t square by 4 from 0 to 10. So you're going to get 25 coulomb. 25 coulombs has passed from 0 to 10 seconds if you take any cross section. Okay, any elementary cross section. And finally we will have one more question. So this question is slightly different in that you have the graphical representation of the charge. So let us say this is the time axis and this is the charge axis, q of t. Okay, and the graph is given something like this. Okay, so this time is given as 1, this is 2, this is 3, and this is 4 seconds. And this magnitude here is 10, this magnitude is minus 10. Now you have to plot the current function, plot I of t. Okay, so we know that I of t is going to be dq by dt. So directly from the graph itself we can do, so we will see how. This is how we will draw. Okay, so at 1 second, this is 2 seconds, 3 seconds and 4 seconds. So from 0 to 1 second there is 1 q of t, the same line. This is a constant and this is a constant. So first if you consider from 0 to 1, it is a straight line. What is the expression of this line? Since it is passing through 0, if you take the line y is equal to mx plus c. Since it is passing through 0, c will simply be 0. So we just need to find out the slope. So what is slope? This is equal to 10 minus 0 by 1 minus 0, right? So you have q of t is equal to 10 times t. And if you differentiate this, then it is simply going to be the slope, right? So I of t are going to get 10 amperes. Okay, and the rest of the time you can see that q of t is constant. Here also it is constant. When q of t is constant, what will happen to its differentiation? It will simply be 0. So the current I is going to be 0 for the rest of the time. Only for 0 to 1 second it is going to have a magnitude of 10 amperes. So this is all about the relationship between current and charge. If current is given, how to find charge. If charge is given, then how to find current. Now a few more points about current before we move forward to voltage. Okay, so direction of current is one important point. Okay, if you take a conductor, it is going to be the charge carriers. What are the charge carriers in a conductor? The electrons are going to be the charge carriers. Okay, as far as conductors are concerned. In semiconductors, you're going to have electrons as well as holes. That's a whole new thing. We'll discuss about it in analog. But for now, in networks, we deal with conductors mostly. And in conductors, what are the charge carriers? Electrons are the charge carriers. Okay. But historically, whenever we talked about charge, we didn't realize that the charge carriers were actually electrons, negative charges. So we thought it was positive charge. So we assigned the direction of positive charge as the direction of current, which is why the direction of current is against the direction of flow of electrons. Okay, so the direction of current is opposite to direction of flow of electrons. Now how do you represent current? The representation is complete only when you know the magnitude, okay, what is the amount of current that is flowing, and also the direction. Okay, so if you take a conductor and let us say this is given as some 10 amperes. Okay, so here you have the magnitude and this is the direction. Without direction, there is no point in representing current. You will not get the entire idea. Now, if you reverse the direction, then you can reverse the polarity. Both of them, they mean the same thing. Alright. Next, we will start discussing about voltage. So, charge and current are not very difficult, but some people might find the concept of voltage to be very difficult. Okay. So, but don't worry, we will get a proper understanding here. By definition, what is the textbook definition? The work done to move a unit positive charge from one point to another. This is the voltage. Okay, so basically you can see that the voltage is nothing but the work done, but per unit charge. So what will be the units? The units are going to be joules per coulomb, right? But because voltage is such a central part of our circuit theory, it has its own units. What are they? It is volts. Okay, so 1 joule per coulomb is equal to 1 volt. And what will be the mathematical expression? The voltage, if you represent as V, then this is going to be the work done per unit charge. Okay, but we will understand in a better way what it is all about. First, we will consider a positive charge here. Okay, so let us say plus Q1. Okay, now what is going to happen if you keep a positive charge plus Q2 here? Okay, let us take this as stationary. Q1 is stationary. That means it is not going to move. Now, whenever two like charges are put together, then what is the force experienced by them? They will experience a repelling force. Like charges repel and unlike charges attract. So now you have two like charges here, both are positive, and this is kept stationary. So what will happen to this Q2? This will experience a force radially opposite direction, right? So this is a straight line between the two of them. So the force experienced by Q2 will be in this direction. What about if it is placed somewhere here? Then also you draw a straight line and then you will get the force direction. So now you can introduce the concept of a field line here. Okay, electric field line. So what is this electric field line? If you take the positive charge Q1, then you can draw lines which are pointing radially outward. These are the electric field lines of a positive charge. So what do they mean? Whenever you keep a positive charge here on any of the line, then that line will give you the direction of force. So for example, you have kept a charge on this line, okay, a positive charge, remember. If you keep a positive charge, then direction of force is in this direction, in the direction of the field line. Similarly, if you keep here, then direction is going to be like this, okay, as simple as that. Okay, now let us say you have a negative charge minus Q1. Then what will be the electric field line direction? This is called as the test charge. Okay, test charge will always be positive. Okay, now whenever we are drawing the electric field lines, we are drawing it with respect to the positive charge. This is the gives direction of force experienced by a positive charge, not a negative charge, by a positive charge when placed on it. Okay, so what will happen now if you take a negative charge? So the negative charge is going to have an attractive force, so the lines will be pointing radially inward. Okay, so now if you keep a positive charge here, what is going to happen? It is going to be attracted, so this is the direction of force, right? So these are the electric field lines. Different kind of charge configurations. They are going to have different patterns of electric field lines. So if it is a line charge or a uniform surface charge or a spherical charge, so these are all some things that we are going to discuss in the field theory. Okay, but for now, to understand the voltage, we will make use of the field lines. It is easier to understand the concept of voltage when you understand it through the field lines. So we will take a single field line here. Okay, so let us say this is a electric field line. Here we will take this as point A. We'll take some two arbitrary points A and B. Okay. Now let us say a charge is placed at this point. Now it has to be moved from B to A. Okay. Now this is the electric field line, that means force is being experienced in this direction. And if you want to change the position of the charge from B to A, then you are moving the charge against the direction of the force. Okay. So some external work needs to be done. You can visualize it in terms of gravitational force. So let us say there is a ground here. This is the ground level. Okay. Now if you want to drop something from a certain height, if you are dropping it, then you just need to let go of your hand. Whatever the object, it is going to fall automatically because the gravitational force is going to pull it down. But what if you have to lift something from the ground? Let's say there is something here, there is a box here which you have to lift from the ground. Then you are doing the work in the direction opposite to gravitational force. So you will have to expend some energy. You will have to spend some energy. Okay. The same thing applies for electric field. When the force line is in this direction, if you have to move a charge from point B to point A, then you're going to have to spend some energy. Okay. Now what is that energy for a 1 coulomb charge? That means you have a 1 coulomb charge which you are trying to move from B to A. Then let us say the amount of work that is done is some x. Let amount of work done to move 1 coulomb charge from B to A be x. Okay. Then this x is nothing but the voltage. Okay. Now 2 more points that you need to understand before you can say that you are perfect with the concept of voltage. What is that? One is the absolute potential. Okay. So there is a difference between potential and potential difference and the polarity. How do we give the polarity? What does the polarity mean? Okay. So first we will start with the polarity. So the same thing, if you can take here, the energy that we will need is, we will need to spend some energy, right? So that means that the potential at A is going to be higher than potential at B. Okay. Because the work done is positive. Okay. You can visualize it in terms of gravitational force. So this is the ground. Now the potential, what is the potential at this point? It is by the virtue of height. So if it is at a height h, then what is the potential energy? mgh. As the height decreases, the potential energy will decrease, right? So similarly, when you move the charge against the direction of field line, then you are increasing its potential energy. So the potential at A will be higher than the potential at B. Okay. So here potential at A is greater than the potential at B. So we can say that A is at positive polarity and B is at negative polarity. Okay. So if you take any circuit element, for example, then here it is positive, here if it is negative, if you take, let us say there is 10 volts. This means that in order to move a unit coulomb charge from this point, from negative point to this point, you are going to need an energy of 10 joules. Okay. So that is what is meant by this. Now sometimes what happens is, we can change the polarity as well. If you want to represent as negative and positive, then what does this mean? The magnitude also you will have to write as minus 10 volt. Okay. So both of these, they mean the same thing only. They are one and the same. So this is about the polarity. What about absolute potential versus potential difference? So we have seen that the potential voltage, it will consist of 2 points. We have to move charge from one point to another point. Okay. But sometimes this point B okay, from where we are moving the charge, let us say it is very far off, okay. So once again we will draw, this is the field line and here we have point A, okay. Now point B, instead of taking here, we will just take it very far away and we will say the point B is here, okay. So now point B is not under the influence of the electric field, okay. Once again, if you take the earth, if you go beyond the gravitational force of earth, you're very far away from earth into the space, far into the space, then you're not going to have the effect of earth's gravitational force, okay. So in that case, we say that the potential at B is 0. The absolute potential is 0, okay. And now the potential difference between A and the point where potential is 0, that is called as the absolute potential at A, okay. So when potential is taken with respect to a faraway point or a point where potential is equal to 0, then it is the potential at that point, okay. So that is the difference between potential difference and absolute potential. So now we have seen charge, we have seen current, the relationship between charge and current, we have seen voltage. Next, what is the relationship between voltage and current, okay. So just like when you drop a ball onto the ground level, it is going to fall automatically. Just like that, if you have some conductor where the potential is given like this, then the current is going to automatically flow from the positive polarity, from the higher polarity to the lower polarity. Because higher polarity is what? If you take the electric field line, then this point if you take A and this point if you take B, then A is at a higher potential, so this is positive, this is negative. Then if a charge is placed on this point, what will happen? It will automatically move towards B, okay. So whenever polarity is given, it means that the current will automatically move from the positive to the negative polarity, okay. So current flows whenever there is a potential difference, okay. And what about the direction? This is from positive polarity to negative polarity, okay. So now if you take a voltage source and you have a resistor connected to it, it is a very simple circuit, okay. So this is, let us say the voltage, if source is giving the voltage Vs, okay. So that means the voltage across this is Vs, okay. So now the current is flowing from the positive to negative polarity through the resistor. Even the voltage source, from positive polarity it is flowing to the negative source, negative side. So this is the relationship between voltage and current. Now we will talk about the network, what is meant by circuit. So we are finally getting into the actual network theory or circuit analysis, okay. So what is the difference between network and a circuit? So you can see that here you have a closed loop, okay. So the current is flowing like this. Now this is a circuit and we can also call it as a network, okay. But for example, let us say there are a lot of resistors here, okay. Now this we can call it as a network, but we cannot call it as a circuit, okay. This is not a circuit. Why is that the case? Because it does not have a closed loop, okay. So the circuit is only the interconnection of elements which form a closed loop. Whereas a network need not have a closed loop. Okay, so it is a mere interconnection of elements. Okay, so this is the major difference between network and circuit. From here you can see that all circuits are networks, but all networks cannot be circuits.